Hi, I'm Hank Lee, a PhD student at Carnegie Mellon University. On behalf of my co-authors, Hiru, Thomas, Jodi, and Sauvik, I'll present our work, Deepfakes, Phrenology, Surveillance, and more, a taxonomy of AI privacy risk. Nowadays, more and more products are designed and created with AI capabilities. For example, we use facial recognition to authenticate into our phones. We use large language model to generate text and support document writing, or we use diffusion-based algorithms to create images and art. Indeed, these shiny new AI technologies make the world very exciting, creating new technology opportunities. But without careful consideration of social impact, these AI-infused technologies can potentially create a large and unsupervised surveillance infrastructure that invades people's lives and breaches their privacy. For example, with facial recognition, a random third party can get access to the ability to match your photos to your online presence. When training large language models, it can be very challenging to ensure the data that the model is trained on or receive users' consent. Or with the capability of generated AI, everyone can create realistic fake photos or videos using others' identity that humans have difficulty discerning as fake. In fact, rather than hypothetical harms that can be caused by AI, these are all real incidents that have occurred and are still occurring in the world we're living in today. So given the recent hype around AI, as well as its malintent, it is perhaps unsurprising to see that people are concerned about AI, how AI can affect their privacy. A recent survey with 10,000 people from all over the world found that many people believe that AI would result in less privacy in the future, citing concerns about collection of personal data, consent, and surveillance. At the same time, there is also a hype about what AI can and cannot do, making it difficult to separate real risk from speculative ones. On that note, it is worth clarifying that the dialogues about AI and privacy are not new. In some way, AI and privacy are bound because many of the privacy risks we talked about come from the collection and processing of personal data, similar to any other computational technology. Nevertheless, something is clear is that the modern advances have really changed the AI and machine learning's capability. And what's not totally clear right now is how these changes and advances in capabilities and the requirement of AI therein to unlock those capabilities have potentially changed about the privacy risk. The foundational question that we are asking in this work is, how does AI change privacy risk, if at all? To answer the key research question, we create taxonomy through a qualitative analysis process. To keep our process grounded in reality, not speculation, we scope our analysis to cases of privacy harms related to real-world AI privacy incidents. We source these from a popular AI incident database, AIAIC. AIAIC is a curated database of over 1,000 incidents where AI causes some types of harms. These incidents were tagged with, for example, harms related to privacy, fairness, transparency. Over 300 of these cases were tagged as being related to privacy at the time we conducted our analysis. We manually analyzed these cases to see if the privacy risk described in each instance was either created by, exaggerated by, or otherwise not meaningfully changed by the capabilities and requirement of AI. We also rooted our analysis against Soliv's popular taxonomy proposed in 2006, which we used as a baseline to capture privacy concerns entailed by computing more generally, before the modern advances of AI. So if the privacy risk described in an incident is captured by Soliv's taxonomy in a manner where the capabilities and requirements of modern AI plays almost no role or very little role, we said it was not meaningfully changed. On the other hand, if the risk described appeared to be different than what was captured by Soliv's taxonomy, we ask if the risk here fundamentally new in some way, or whether capabilities and requirements of AI exacerbate this risk that we've known about. Very briefly, we identified in total 12 types of AI privacy risk and found that 93% of the incidents described involve a situation where the capabilities and all the requirements of AI either create or exacerbate the described risk. We also created a website at aiprivacytaxonomy.com to increase the reach of our work. In this presentation, I will highlight a few of the privacy risks related to the collection, processing, and dissemination of data. For the full list of privacy risks as well as associated case studies, please refer to the website and the paper. Let's first talk about risks that AI exaggerates. So these are risks that have always existed, but that's something about the capabilities and requirements of AI can extend its intensity and scale. First, of course, surveillance, which is always a big concern when we talk about computing technologies that are constantly watching, listening to, or recording an individual's activities. So surveillance have long existed before AI, but AI exacerbates the risk by incentivizing the collection of ever more data to train and deploy effective models. There are reports, for example, schools that deploy student safety management tools to detect and prevent violence and suicides, but end up monitoring students' digital footprints like emails, online documents, internet usage, and social media accounts. Or reports in which employees' geolocation data from mobile devices were used to assess their performance, raising concerns about employee tracking even outside their work. Next examples of surveillance of increased scales and ubiquity are incentivized by the promise of AI being able to sift through this data to make sense of it very easily. Second, identification risk. Another well-known privacy risk entailed by AI refers to linking specific data points to an individual identity. For example, a picture of your face may not link to your identity by default, but with facial recognition technology, it's more easily to do so. AI technology can simplify and automate the identification process, looking across different sources in large scale, often in real time, and even with low quality or obfuscated data. An example of this is Clearview AI, a facial recognition software that allows a police officer to index into your online presence in real time with just a photo of you, even when you're wearing a hat or glasses in the photo, or with only partial view of your face. AI can also exacerbate insecurity risk, which refer to the carelessness in protecting collected personal data. Indeed, AI does not always meaningfully change insecurity risk. A good example of this is when an AI product had a data breaches when being hacked, which happened to a startup that provides cloud-based security cameras with facial recognition. The attackers then got access to these AI-powered cameras and their facial recognition data. But AI can exacerbate insecurity beyond being simply best words in that sense. Memorization risk in large language model, or short for LLM, is a very good example of this. So LLM can memorize training data and reveal sensitive data of a user to other users given a particular prompt. And there's an example of this in our dataset. A chatbot trained on real-world text conversations was found to expose information like the names and home address of the users whose data on which the bot was trained on. So let's switch gears and talk a bit about risks that AI creates. So we found that AI can create two types of new risk: new instantiation of known categories of risk and new category of risk. So one new instantiation of risk is in distortion category, which refers to disseminating false and misleading information about people. So AI creates new types of distortion risk, and that we typically hear of is misinformation through deepfake, which exploits one's identities to generate realistic fake images and audio that humans have difficulty discerning as fake. In our dataset, we found 4chan users have used the fake technologies to create audio of celebrities saying homophobic and racist things that they had never said before. We also found AI created distortion risks that are less egregious. A filmmaker of a documentary used the fake to create scenes of an actor who had passed away for lines he had no recordings of. So this example also raised important questions about expectations around privacy in light of how generated AI can and should be used in different use cases. Finally, we found that there's a new category of risk that wasn't well captured by the original Solve's taxonomy that AI is enabling. And this is privacy risk related to phrenology and physiognomy. So physiognomy is a pseudoscience that purports that one can understand a person's character or personality traits like their intelligence, likelihood to commit a crime, by simply examining their physical features like face or body. In our data set, we found attempts, for example, to use AI to classify people as gay or straight, or whether or not they are criminals based only on the picture of their face. Besides the problematic use of AI, these also raise privacy concerns where user-sensitive information is being inferred and potentially shared. To conclude, in this work, we identified 12 privacy risks that AI can exacerbate and create through an analysis of over 300 real-world cases. We also identified two main areas for future work. First, we should broaden the design space for privacy-preserving AI. So considering common notions of privacy-preserving machine learning for now, typically two main things come up: differential privacy and federated machine learning. There are useful techniques for sure, but based on our findings, they only consider a small subset of the AI privacy risk. They consider some of the processing risk exacerbated by AI and do not at all consider the data processing and dissemination risk newly created by AI. For example, we could create a differentially private algorithm to classify whether or not a person is a criminal based on their face in a federated machine learning architecture, and that's not going to eliminate the privacy risk. Future work should fill the gap of mitigating privacy risk created and exacerbated by AI by creating AI-specific privacy guidance, in which our taxonomy opens up a new design space for privacy-preserving AI tools that aim to raise practitioners' awareness of AI utility and intrusiveness trade-offs of their product ideas. Second, the capabilities and requirements of AI almost certainly to change with future advances. So too might AI privacy risk. While we haven't seen real-world cases, we can envision new types of privacy risks entailed by AI in the near future. For example, AI can create new interrogation risks, which refer to the covert collection of data when a person is being actively questioned. LLM powered chatbots like ChatGPT, for example, could create new interrogation risks by imitating people interacting with users in natural languages, aiming to extract more personal information from them. Thus, we see our taxonomy as a living structure that helps scaffold the conversation about how advances in AI change privacy risk, and future AI privacy incidents can also expand the taxonomy as well. With that, this concludes my presentation, and we encourage you to visit our website and paper to learn more. Thank you for your attention.